video is part 2 of the Pythagorean Identities video series that Mr. Whipple and Mr. Dodge are putting together for Bow High School pre-calculus students. So what I'm going to do with you today is start with the original Pythagorean identity that was developed in the last video, which is that the sine squared of theta plus the cosine squared of theta is equal to 1. Remember that for the right triangle that you used on the unit circle, we had the opposite side equal to the sine of theta, the adjacent side equal to the cosine of theta, and the hypotenuse equal to 1. And so we get that one side squared plus the other side squared is equal to the square of the hypotenuse. And what we'd like to do today is to use this equation and derive another trigonometric identity that relates tangent and secant. So we're going to begin by dividing every term in the equation by the cosine of theta squared. So as long as I do that everywhere in the equation, I will obtain another identity. Looking at this equation that we now have, the first thing that pops out at me is that the cosine squared of theta divided by the cosine squared of theta is going to equal 1. So I'm going to have a plus 1 right here. So the challenge now becomes to figure out what the other two terms are going to become. This term is 1 over the cosine of theta quantity squared. And the term here, if I do a similar thing, rewriting the expression as the sine of theta over the cosine of theta quantity squared. And remember, I can do that because one thing squared divided by another thing squared is the same as taking the ratio first and then squaring it. This leads to something that's great for us, which is that we've introduced new trigonometric functions into the equation. We recognize that this is where the first term, sine of theta over the cosine of theta, is equal to the tangent of theta. And also that the reciprocal of cosine of theta is equal to the cosecant. Whoops, excuse me. I should talk to you about the interesting aspects of how the trig functions are defined, but I won't. I'll just remind you that the reciprocal of cosine is secant of theta. So now, substituting these trigonometric functions back into the original equation, we will have that the tangent squared of theta plus 1 is equal to the secant squared of theta, which is the other Pythagorean identity that we were seeking to demonstrate. Now, there's one more added bonus that we can get here. If, instead of having secant isolated, we have the tangent isolated, we may want to rewrite this identity by subtracting 1 from both sides to yield another identity, which will be that the tangent squared of theta is equal to the secant squared of theta minus 1. So, the two trigonometric identities that we have proven are tangent squared of theta plus 1 equals secant squared of theta, and tangent squared is equal to the secant squared of theta minus 1. Okay.